Hey, Math 10. Today we're going to be learning about surface area. So you should be able to find these surface area notes in our Microsoft Teams. And we're going to be talking about this kind of stuff. And so these are the notes. You can kind of do this. The other thing that you'll find in there as well is that you'll also find some additional worksheets so that you can work on it yourselves. And then I will post the answers to those worksheets later. See how you did. And then later on, we'll have a little quiz on surface area. So first off, some note stuff is that surface area. So let's get some writing here. So surface area let's zoom in just a tiny bit, is the area that would be covered by paint if you were to paint something. Okay, so it's just all the outside stuff, that surface area. In other words, what you'd be covering with paint. You wouldn't be painting on the inside, just the outside kind of stuff. So here's our first question. It says, find the surface area of a waffle cone that has a diameter of 3 inches. This little double quotation mark thing means inches. If it has like a single quotation mark like this, 3, and then just like 1 right there, that means 3 feet. So this would mean 3 feet, 3 inches, 6 feet, 2 inches. Okay. And a slant height of 6 inches. So if you're unsure what a waffle cone is, they look like this. Now they have like this big textury pattern, which would increase the surface area. But for all of these purposes, we're just going to say that it's a smooth cone. Okay. And that's going to make the numbers a little bit easier for us. So here's our waffle cone. And the next thing is like, that's all the information that it really gives us. So we should have a formula sheet associated with this so that we can look up our formula sheet. So I'm going to look up the formula sheet right now. And here is our formula sheet, right like this. Where did I lose it now? There it is. Okay, so here's my formula sheet. I'm just going to pull this thing over to take that. Here's our surface area thing like there. Okay, so we have our formula sheet right here. You can find this on the file section of Microsoft Teams. And here we see our cone right there. There's our surface area. We have volume right here, but we're not going to be talking about volume today. And it asks us find the surface area of a cone that has a diameter of 3 inches and a slant height of 6 inches. So here it is right here. The total surface area is pi r squared plus pi r s. Now, that is if the cone had this kind of lid on it. This would be it right here. Now, what would happen is that if we're trying to find out the surface area of this waffle cone, if you know about a waffle cone, this part right here, there is no top to it. In other words, there is no base to it. So in other words, if we were to make this like kind of cut this thing out right like this, our cone would kind of look something like that. Okay, so this is what our cone would look like. There is no top to it. So in other words, since there is no base, we're just going to be using the area or the surface area of the side, which is pi r s. Okay, so we want the area of the side equals pi r s. Okay. Now, we're going to be talking about this a little bit more, but area of the side, pi r s, this formula only talks about the surface area of the outside of the cone. Okay, so say if we want to know how much surface area we have to dip chocolate in, and we're only going to be dipping the outside of the cone in chocolate, well, that's kind of what we want to know. So we're going to kind of answer it in that way, and then I'll come back to that in a little bit later. So pi, so the area of the side, equals pi, which is 3.14. And if you have a scientific calculator, you should have a pi button. And on that pi button, it should give you more digits than just 3.14. But you can just use 3.14. That's fine. Now it says R, and R stands for the radius. And it kind of gives you a little picture of what the radius is right here. So we're going to go back to our picture right here and kind of fill in where is the radius. I'm just going to kind of erase some of this stuff right there. So the radius, which says it has a diameter of 3 inches. So that means this whole length right here is 3 inches. So this length, which is the radius, going back to our picture, that is going to be the radius R, which equals half of the diameter, which is 1.5 inches. Now, the slant height, S, is this length right here. That kind of goes at this angle. And it says the slant height is 6 inches. So it's going to be 3.14 times the radius, which means times 1.5 times the slant height, which is 6. Okay? So we're going to do that into our calculator. We're going to go 3.14 times 1.5 times 6 equals, we get 28.26. Now, since the question gave it to us in inches, our answer will also be in inches, but since we're dealing with surface area, it's going to be inches squared. Okay? And so this is the surface area of the outside of the waffle cone. Now, if it was asking what is the surface area of the outside of the waffle cone and the inside of the waffle cone, well, then you'd have to double this number. But let's just imagine we were going to put chocolate on the outside of the waffle cone and not on the inside, and so therefore this is what we want in there. Okay. Now we have a lot more complex question right here. We have two objects right here. We have a cylinder, which is up here, and then we have a rectangular prism, which is down here. So I'm going to deal with a few things first. And so first off, from our last unit, we have something that is in feet, and we have something that is in inches as well. So we have to just choose one unit, okay? So what we're going to do is, just to make all the numbers smaller, I'm going to choose feet for everything. So if I go into this sheet here and I go to the very top, I'll find something that says 12 inches is equal to 1 foot. Okay? So I have 36 inches right here. So if I go 36 times 1 foot over 12 inches, these inches will cancel out. So it'll be 36 times 1 divided by 12, and this will equal 3. So this length right here is going to be 3 feet. Okay, so I'm just going to kind of write here 3 feet. Now I'm going to do this one as well. This says 42 inches right here is the height of this cone. And so I'm going to go 42 divided by 12, and I get 3.5 feet. So again, if I was to do this, it'd be times 1 foot over 12 inches. So in other words, 42 times 1 divided by 12, and that's going to equal 3.5 feet. Okay, so now I've effectively changed everything into feet. So this is 10 feet is the length of this one right here. 9 feet is the length of this thing. 3 feet is from here to the very top of right here. 3.5 is this length. 2 feet is this length. Okay. Okay. So now what we're going to do is we're going to find the surface area of this rectangular prism, which is this one right here. And we have this big long formula. And it says width times height times width times height plus length times width plus length times width plus length times height plus length times height. In other words, you're just finding the surface area of all these panels right here and then adding them all up. And that's what you're essentially doing. Now, here we have this one panel right here, this big panel that goes all the way across here, but it has this little circle cut out of it. But if you kind of see, yeah, that little circle is cut out, but there's a little circle right here. So we can just kind of count this whole thing and go from there. So I'm going to find just the surface area of this whole big box right here. And I'll kind of show you what I mean. So first off, I'm going to use this formula right here. It's a little bit more concise. So it says surface area equals, now this width times height times length times width plus length times height. It doesn't actually matter which one you decide to make height, length, or width. So yeah, it doesn't matter at all. But we'll go 2 times, and I have the formula right here. So I'm going to go 9 times 10. 9 times 10. I'm going to write plus. Okay. And 3 times 9, we'll say. 3 times 9 plus, and then we'll go 3 times 10. 3 times 10. Okay. So surface area equals, and I'm again just using this formula over here, 2, I'm going to do inside the brackets first. 9 times 10 is 90 plus 3 times 9 is 27 plus 3 times 10 is 30. Okay. Then I'm going to add all these things up together. So this is just going to become surface area for this box is going to equal 90 plus 30 is 120 plus 27 is 147. Okay. Now, surface area equals 2 times 147. So 2 times 147 is 294. So the surface area of the box, the surface area of the box is equal to 294. And that is going to be feet squared, okay, or square feet, what we say. Now, this is not our final answer. This is just the surface area of the box, okay? Now, this is the surface area of the box that is including this little circle right here. But if you notice, this little circle right here is the exact same as this little circle right here. It's just that we're kind of taking this little circle right here and putting it back down there. So now I need to find out what is the surface area of that cylinder. Now, we've already taken that little circle right here and kind of put it down here and made it part of that box again. So all I need to do is essentially find the surface area of the side of this cylinder. So I only need to use this surface area of this side of this cylinder right here. So I'm going to go area of the side equals 2 pi r h. 2 pi r h. R stands for the radius. We don't know the radius. We've been given the diameter. So the radius is half of the diameter. So the radius is going to be 1. So I'm going to write area of the side again equals 2 times 3.14 times the radius, half of 2, which is just 1, times the height. The height of the cylinder, which happens to be 3.5. Okay. Now I'm going to multiply all those things up. So I'm going to take my calculator, put down my pen. 2 times 3.14 times 1 times 3.5 equals, and I get 21.98. Again, everything is in feet, so we can keep it in feet. But since we're doing area, it's going to be square feet or feet squared. And that is going to be the area of the side of this cylinder part right here. Now, if I want to find the total surface area of this weird kind of object, I need to add these two things together. So this number and this number need to come together to make the total. And so that's, again, and the important thing is that I kept everything as feet right here. So if I did this one in inches and this one in feet, I cannot add them together. I have to keep everything as in square feet, and then you're able to add it together. So 21.98 plus 294 equals 315.98 feet squared. Let's double box it so that we definitely know that it's the right one. Okay, so that's how we find out the surface area of what we call a composite object, or in other words, an object that is has multiple objects within it. Okay. Okay. We have two more right here, and we're going to try and do these ones nice and quick. Here we have Jason has been hired to paint the exterior of a storage bin. If the bin is a rectangular prism that measures 2.3 yards by 4.4 yards by 2.8 yards, what is the surface area of this bin? So what I'm imagining here in this question is that it's one of those kind of metal storage bins that you can sometimes see by our school right there that stores a bunch of stuff. They have big doors and everything like that. But so 4.4 yards is a large kind of object. To give you an example, this would be roughly like what the storage bin would look like. Something like that. That's what the storage bin would look like. And to give you a height comparison of something is that it would be like this would be roughly the height of an adult person. Okay, so that would be like roughly the height of someone. Okay, so it's a big thing. So when it says this person, Jason here, has been hired to paint the exterior, the outside of this thing, we are going to assume that they are not painting the underneath of this storage bin. Okay, so we're going to ignore one of those sides. So when we think about like using this rectangular prism formula, this is a very good formula, but it says that you're painting absolutely everything, and you're not going to be painting the bottom of this thing, just the roof, the walls on the outside, not the bottom. Okay, so I'm going to plug in some numbers right here. Let's say this is 2.8. 2.8. This is this height right here is 2.3. Okay, and this length or right here is 4.4. So first off, really nice that we have all the same units. If we didn't have the same units, if we had feet in some of them, or if we had centimeters in some, we'd have to convert a bunch of things to make sure that it's all the same units. But thankfully, they're all the same units, so we can start kind of going away and working on this thing right here. So the next thing is that I'm just going to kind of draw some some lines that kind of go like that, so we can kind of see through it. Now, so the first things that we're going to go is we're going to do surface area. And we're going to go this area right here of this particular wall right here. Okay, which is going to be 2.3 times 2.8. Okay, so that's going to be the surface area of just this one wall I shaded right there. Now, there happens to be another wall right there of this one right here on this other side right here, and it has the exact same dimensions. So we can actually go 2.3 times 2.8 times 2, and those are those two walls that I just shaded right there. Okay, and I'll calculate this a little bit later. Now we have another one right here. We have the surface area of these very, very long walls right here. And it looks like this big long wall, which is going to be 2.3, because the height of this is 2.3, times 4.4. Okay, now there's this other one that's way over here as well. Okay, and so again, times by 2. And then we have the surface area of this thing right here is going to be, of the ceiling right here, is going to be 2.8 times 4.4. Okay, now I'm noticing a little bit of a problem right here. It says Jason has been hired to paint the exterior of the storage bin, and we actually don't know which side of the storage bin is down. Like, I kind of assume that it would be like this long side would be down, this 4.4 yards by this 2.8 yards would be down. You wouldn't have to paint that. But technically speaking, it doesn't say that the bottom, this side is down. It could be that the storage bin is looking like this too. You know, like it could be like this, and this side is down. It'd be a very, very weird way to have a storage bin. But technically speaking, it could be this way is the side that is down, and you'd have a lot more surface area. So let's just kind of change the question right here. Since we don't know what side is down, Jason has the very difficult task of, after he paints everything, he has to roll it over and paint the underneath of it. So we're going to say that he has to paint the bottom of it too. So I'm going to change that a little bit and say we have to times that by 2. Okay. So in other words, we are using just this whole formula right here. This, even though I broke it into 3 parts, I went times 2, times 2, times 2. That's the same as using this thing right here. Okay. So just because we don't know which side of the storage bin is down, so we're just going to say Jason has the unfortunate task of painting the whole entire thing. So we're going to go 2.3 times 2.8 times 2 equals, and we've got 12.88 for these two sides, 12.88 for that. And we have 2.3 times 4.4 times 2 equals, and we got 20.24 for these two walls right here. And we're going to go 2.8 times 4.4 times 2 equals 24.64. Now what I'm going to do is I'm going to add up all these surface areas of the walls. So 24.64 plus 20.24 plus 12.88 equals, and we get 57.76. 57.76. Now, since everything is in yards, our answer is also going to be in yards, but it's going to be squared. So square yards. Okay, and that is how much surface area he has to paint for this storage bin right here. Okay. Canning factory wants to use as little metal as possible when it makes the cans. It considers two sizes of cans to hold the same amount. One is 4.5 inches tall. So I'm going to draw a picture of a can right here. One is 4.5 inches tall. So here's 4.5 inches tall roughly, with a radius of 4.2. So right like that. So if that's the radius, and that would be the diameter. It's a very wide can. Okay, just going to kind of erase this side right like that. Maybe, oops. There's our can. It took me a little while. Anyway, it's 4.5 inches tall, so we're going to write 4.5 inches. The radius, which is just from the center out to the side, is 4.2 inches. So 4.2. And so that's our one can right there. And the next can is 9.6 inches tall. So much, much taller. And it has a radius that is much, much more narrow. So this is 9.6, and the radius from here out is 2.8. So we want to see which one has a smaller surface area. So we're going to go up to our cylinder section, and it says surface area for this one is 2 pi r squared plus 2 pi r h. So surface area equals 2 pi r squared. So 2 times 3.14 r squared, 4.2 squared. Forgot my little times table. Plus 2 pi r h. So 2 times 3.14 r 4.2 h 4.5. Okay, so surface area equals, you should be doing exponents first. So go 4.2 squared. So I'm going to go 4.2 squared times 3.14 times 3.14 times 2. So I get 110.78 plus, I'm going to do this section right here. So it's going to be 2 times 3.14 times r, which is 4.2, times our height, which is 4.5. Okay, and I get 118.69. So the surface area of this can, or these two numbers added up, so plus 110.78, I get 229.47, and that's going to be inches squared. So that is the surface area of this short fat can. Okay. Ooh, really running out of room on this one. Okay, let's see if I can do this. Okay, so I might have to go kind of backwards up here a bit. So our surface area equals 2 times 3.14 times our radius squared, which happens to be 2.8 squared, plus 2 times 3.14, so 2 times 3.14 times our radius again, 2.8 times 9.6. Okay, so first part, surface area equals 2 times, exponents first, 2.8 squared times 2 times 3.14 equals, and we have 49.23. And then we're going to go 2 times 3.14 times 2.8 times 9.6 equals, and I got 168. 168.8. And so the surface area of this one equals plus 49.23 equals 218. And we'll say inches squared. So which of these cans is the a little bit better in terms of using less material? Well, it seems like this can is a little bit better for using a little bit less material. Okay. Try doing the practice problems that are below, and yeah. Anyways, and then we'll have a quiz on this later this week. Okay. Good luck.